Hi everyone, for today's lesson we are going to learn about how to perform function compositions, which means that instead of just letting x equal a number, we're now going to be letting x equal a function. So we're going to be substituting functions into functions. And that's what a function composition actually is. But before we get started, I would like you to please factor these three expressions. The first one is 64x cubed minus 8. The second one is 2x to the 5th power minus 12x cubed plus 10x. And the third one is 2x cubed minus 7x squared minus 8x plus 28. Please pause the video and factor each one of these. Factoring will be on your next test, so I want to make sure that you guys are genuinely prepared for that section of the test. When you have an answer, please go ahead and restart the video. All right, hopefully in number one you recognize that 64 and 8 have something in common, and that is the number 8. So the first thing you want to do is factor out a GCF. You'll be left with 8x cubed minus 1, and 8x cubed minus 1 is a difference of cubes, which means that you'll be using SOPs to help you to factor that and break it down even further. So I have 8 times a binomial times a trinomial. In your binomial, I'm going to take the cube root of your first term, which is 2x, and the cube root of the last term, which is going to be minus 1. The minus remains constant. Then I'm going to do square, opposite, product, square. 2x squared, that is 4x squared. Don't forget to square the 2. Opposite of a minus is a plus. Product, 2 times 1 is 2, so we have 2x. And then squared, negative 1 squared is a positive 1. And that is the answer for the first one. For the second one, 2x to the 5th minus 12x cubed and 10x all have in common a 2, and they all have in common an x. So I'm going to factor out a 2x, and my leftovers is x to the 4th minus 6x squared plus 5. I'm going to split the trinomial apart into 2 parentheses, splitting apart the x to the 4th into an x squared and an x squared. And I have to figure out what two numbers multiply to equal positive 5, but together add to equal negative 6. And that's a negative 1 and a negative 5, so I'm going to write minus 1 and minus 5. X squared minus 1 is a difference of 2 squares, so it's a dot. So we're going to have to break that parenthesis down even further. So we have 2x times x plus 1 times x minus 1 times x squared minus 5. X squared minus 5 is not a dot, and that's because 5 is not a perfect square number. Next, we have number 3. Whenever you see 4 terms, immediately try factoring by grouping. So I'm going to put parentheses around the first 2 terms. I'm going to change that middle sign to be a plus negative, and I'm going to put parentheses around the negative 8x plus 28. Now I'm going to factor out the GCF, and 2x cubed and 7x squared have in common an x squared, with our leftovers being 2x minus 7. Plus, if I do this correctly, I should end up with a 2x minus 7 in the other parentheses. So negative 8 and 28 have in common a 4, but because I want my leading term to be positive, I'm going to factor out a negative 4. And I can always check. If I multiply negative 4 times 2x, I end up with negative 8x, and negative 4 times negative 7 is positive 28. So I'm going to rewrite this as 2 parentheses. We have an x squared minus 4, so that's my outsiders. And then my 2 parentheses that each part has in common, which is a 2x minus 7. It looks like I'm done, but I'm not. X squared minus 4 is a dot. So it's a difference of 2 squares, so I'm going to break that down into an x plus 2 times an x minus 2 times a 2x minus 7. And that is your final full factorization. If you struggled with any of these 3, or you made an error along the way, please make sure that you get in contact with me as soon as possible, because factoring is not going away, and like I said before, it will certainly be on your next test. So at the very beginning of this video, I talked about what this lesson is about, and that is about performing compositions of functions and identifying the domain of the result. So that's the I can statement. I can perform compositions of functions and identify the domain of the result and I can perform compositions of functions to solve real-world problems. The real-world problem that we have in this lesson is kind of nice because it relates to what many of us will be doing this season, and that is going shopping and hopefully having coupons in our hands. So that's what the real-world problem is about. So another operation that can be performed between two functions besides addition, subtraction, multiplication, and division is composition. And composition means that instead of just substituting a number in for x, we're going to substitute full functions in for x. That is what a composition is. So the composition of a function g with a function f is called this. H of x equals g of f of x. If you notice in this, what you see here is instead of saying simply g of x, we have g of f of x. That means you're going to plug f of x into every x value of g of x. That's what this means. You're going to plug f of x, whatever that function, into every x value of g of x. And we read this as g of f of x. That's how we read this, g of f of x. And so what we're going to be doing is we're going to be starting on the inside and working our way out, and we're going to be evaluating functions. So I'm going to write down that whenever you're doing compositions of functions, you start on the inside and work your way out. So this is supposed to be an O, on the inside. And work your way out. And that's how you solve a composition. Start on the inside and work your way out. With, of course, a smiley face. Here we go. Example number 4. There are 2 steps in starting on the inside and working your way out. We have f of x is equal to 3x minus 4, and g of x is equal to x squared minus 1. And we want to find f of g of negative 3. So there are 2 parts that we need to work with. The first thing that we need to do is identify what number g of negative 3 produces. Then we're going to perform the f part of that function. So step number 1 is we're going to identify what g of negative 3 is. That's starting on the inside and working our way out. So I'm going to let x equal negative 3 into our g of x function. So I'm going to say negative 3 squared. I'm going to use parentheses because you want to make sure that you're very deliberate about your substitution. So I have negative 3 squared minus 1. This is equal to 9 minus 1, which is 8. So g of negative 3 is equal to 8. So now that I know what g of negative 3 is, I now can say that f of g of negative 3 is equal to f of 8. So I just replaced g of negative 3 with the answer I found in step 1. This is f of 8. So f of 8 means that I'm going to substitute 8 into my f function. So I'm going to write 3 times 8 minus 4. 3 times 8 is 24, and 24 minus 4 is equal to 20. And that is our answer. So we can say that f of g of negative 3 is equal to 20. The first thing that we did is we identified what g of negative 3 was. That gave us the result of 8. Then we substituted 8 into our f function, and it came out as the number 20. And that is our answer. Let's go ahead and look at letter B. For letter B, this is different. There is no number that we're substituting in. We still start on the inside and work our way out, but the difference this time is that there's not a lot to do in that first step, other than to identify what g of x is. So g of x, that's equal to x squared minus 1. I always identify what g of x is, or what our inside is. Then step 2, if we're talking about f of g of x, that means I'm going to replace g of x with what it is. So that's going to be f of x squared minus 1. So that means that at every single quote-unquote x value, I'm going to substitute x squared minus 1. So this function is 3 times something minus 4. That's what our f function is. 3 times something minus 4. And example letter B, the something that we're going to substitute in is going to be x squared minus 1. So I'm going to write this as 3 times x squared minus 1. And then I'm going to subtract 4 from that value. So all I did was substitute x squared minus 1 into my position where my normal x would be. Now I'm going to simplify this by using the distributive property. And I have 3x squared minus 3 minus 4. And that is equal to 3x squared minus 7. So therefore, f of g of x is equal to 3x squared minus 7. And that is our answer. And finally, we have g of f of x. So we're starting on the inside and working our way out. The first thing that we want to do is identify what f of x is. F of x is equal to 3x minus 4. Step 2, I'm going to identify what g of f of x is. So I'm going to replace f of x with 3x minus 4. So this is g of 3x minus 4. And so in my g function, I have x squared minus 1. So that means I'm going to substitute something in for x. I'm going to square it and then subtract 1. And the thing I'm going to substitute in is 3x minus 4. So I'm going to write 3x minus 4 squared minus 1. Now you have to be careful. Do not distribute the exponent. So I'm going to write be careful. What we have here is a PST. This is going to be a perfect square trinomial. So I'm going to rewrite this as 9x squared. 3 times 4 is 12. 12 times 2 is 24, so minus 24x. And negative 4 times negative 4 is 16, so plus 16 minus 1. And all I did there was I used my trick for perfect square trinomials. If you need to write out 2 parentheses and then FOIL it in order for you to get down to here, that's perfectly fine. So now I have 9x squared minus 24x plus 15. And this is equal to g of f of x. So I'm going to write g of f of x is equal to 9x squared minus 24x plus 15. And that is my answer. All right, let's go ahead and look at example number 5. For example number 5, we have 2 new functions. The first one is 3x minus 8 is f of x, and g of x is 2x squared. The first thing we're going to do is g of f of 5. So the first thing I'm going to do is start on the inside and work my way out. So I need to identify what f of 5 is. So f of 5 means I'm going to substitute 5 into my f function. So that's going to be 3 times 5 minus 8. That's 15 minus 8, which is 7. So f of 5 is 7. So now I'm going to identify what g of f of 5 is. So f of 5, we found that to be the number 7. So I'm going to write g of 7. And now I'm going to substitute 7 into my g function. So that's going to be equal to 2 times 7 squared. Please be careful. Do not make that 14 squared. We have to follow the order of operations that says that we have to do the exponents first. So 7 squared is 49, and 49 times 2 is 98. So that means that g of f of 5 is equal to 98. That is our final number. Let's go ahead and look at letter B. For letter B, we have f of g of 5. So starting on the inside and working our way out, we're going to identify what g of 5 is. G of 5 is where I'm going to let x equal 5 into my g function. So I'm going to write 2 times 5 squared. Once again, please be careful and follow your order of operations. We have to do 5 squared first. That's 25, and 25 times 2 is 50. So g of 5 is 50. The second thing I'm going to do is identify what f of g of 5 is. Since g of 5 produced the number 50, I'm going to write f of 50 and substitute 50 into the f function, which the f function is 3x minus 8. So I'm going to do 3 times 50 minus 8. So that's going to be equal to 150 minus 8. And that is equal to 142. So 142 is my answer. So I would say that f of g of 5 is equal to 142. And finally, we have f of x. So f of x means that we're going to substitute f of x back into itself. So the first thing we need to identify is what f of x actually is equal to. And in this case, it's 3x minus 8. So I know that f of x is 3x minus 8. Next, I'm going to identify what f of x is, which means that I'm going to replace f of x with 3x minus 8, since that's what it's equal to. So f of 3x minus 8. So that means I'm going to substitute 3x minus 8 in for x. So this is going to be equal to 3 times 3x minus 8 minus 8. I'm going to use the distributive property to get 9x minus 24 minus 8. And that's going to be equal to 9x minus 32. So f of x is 9x minus 32. And that is your answer. So now what we're going to do is we're going to come up with, we're going to be doing some a little bit more complicated compositions on the next page. So this time around, we are given that f of x is equal to 6x to the negative second power, and g of x is equal to 4x plus 5. For this one right here, for the f of x function, please be careful. This has a negative exponent, and it would be in your best interest to rewrite this as f of x is equal to 6 over x squared. This exponent is not happy where it's at, so it needs to be brought down. Now notice that we have an x value in the denominator, which means that at some point in time you'll have to restrict the domain. And I'll talk about when to restrict the domain in just a moment. So let's go ahead and identify what f of g of x is. The first thing that we want to do is identify what g of x is. And in this case, that is 4x plus 5. The second thing we want to do is substitute 4x plus 5 in to your f function. So I'm going to write this as f of g of x is equal to f of 4x minus 5. So I'm going to substitute 4x minus 5 into my f function. So that's going to be 6 over 4x minus 5 squared. Now, it's important that you have it written like this at some point in time, because this will help you to identify your domain. But what I'm going to do here is, if you notice that we have ourselves a parentheses squared, that's going to be a perfect square trinomial. So I'm going to use my patterns, and this is going to be 6 over 16x squared. 4 times 5 is 20. 20 doubled is 40, so minus 40x. And negative 5 squared is 25, so plus 25. And that is your answer. Like I said, though, you're going to want it in this factored form for when you're identifying your domain, and we'll talk about that in just a second. Let's go ahead and look at letter B. For letter B, we have g of f of x. So g of f of x, the first thing we want to do is identify what f of x is. F of x is 6 over x squared. Step 2, we want to find what g of f of x is. And I'm going to replace f of x with 6 over x squared. So this is g of 6 over x squared. So that's going to be equal to 4 times 6 over x squared plus 5. This 4 is like a 4 over 1, and we can multiply straight across. And we'll end up with our answer being 24 over x squared plus 5. And we're simply going to leave our answer just like that. Once again, notice that we have ourselves a variable in the denominator, which means that when we identify our domain, there will be a restriction on the domain. And finally, for letter C, we have g of x. So the first thing we want to do is identify what g of x is. And g of x is 4x plus 5. So now g of x means that I'm going to replace the interior g of x with 4x plus 5. So that's going to be g of 4x plus 5. So I'm going to substitute 4x plus 5 into my g function. So that's going to be 4 times 4x minus 5, 4x plus 5 plus 5. So that is 16x plus 20. I'm just distributing the 4 to each term, plus 5. So our function for g of x is 16x plus 35. Notice that at no point in time there was a variable in the denominator, there wasn't any even roots, so that means that it's going to have a different kind of domain as the other two. So now letter D says, identify the domain of each composition. So looking at letter A, we had f of g of x. The domain for f of g of x is going to be restricted, and that's because we have a variable in the denominator. We are not allowed to have a denominator that is 0, so what we need to do is identify at what point in time or what 0 or x-intercept would be produced from 4x minus 5. So if you want, you can say 4x minus 5 is equal to 0 and solve for x. By adding 5 to both sides, you end up with 4x is equal to 5. Dividing both sides by 4, we end up with x is equal to 5/4. If x equals 5/4, then that means, I'm sorry, I think I did this incorrectly. This is a plus. I'm going to change that to a plus. Sorry, you guys, because that was a 4x plus 5. Excuse me. So then that makes this a plus. That's a minus. That's a minus. This is a minus, and this is a minus. Okay, so if x is equal to negative 5/4, if x is equal to negative 5/4, then that means that our denominator would equal 0. And if our denominator equals 0, then that means that we have ourselves an undefined fraction. And if we have an undefined fraction, then that doesn't work. So that means that our domain will be all real numbers except x cannot equal negative 5/4. All right, so that was letter A. Letter B, we ended up with a denominator with a variable in it. So once again, we need to figure out what value of x needs to be eliminated. So we're going to let x squared equal 0. I'm letting my denominator equal 0. I'm going to take the square root of both sides, and I find that x equals 0. What this means is if x equals 0, then we have an undefined fraction and an undefined answer. So therefore, for g of f of x, our domain needs to be all real numbers except x cannot equal 0. And for letter C, at no point in time did we end up with a variable in the denominator. And because at no point in time we ended up with the variable in the denominator, and at no point in time did we have an even root, that means that for g of x, there will be no restriction on the domain. It will simply be all real numbers. So the question is, when should I restrict the domain? So I want you guys to write this down because I think that this is very important. When should I restrict the domain? Well, the first thing you would need to see is if at any point you have an even root anywhere in the problem. That means that you'll have like a square root, a fourth root, a sixth root, an eighth root somewhere in your problem. And if you have that, then that means that you'll have to restrict the domain to being all values of x being greater than or equal to some number, making sure that the number under the root is a number that is 0 or bigger. The second thing is if you have an x anywhere in the denominator, at any point in the problem. So even if your variable eliminates at any point in time, it's still important for you to establish that you have a restriction on your domain as a result of that variable being in your denominator at some point in time in the process. So if you don't have any of these taking place, then you have no restriction on the domain. Otherwise, this is when you would see a restriction on the domain. Please be careful and make sure that you study this very, very much. And pay attention whenever you're doing your homework. We have one more problem and then we are finished with this lesson. So it says Heather purchases water skis with a price tag of $180, but we're not going to work with that $180 quite yet. So since price can vary, we will represent with X dollars to start this problem, and then we'll go back to working with the 180. The sports store applies a newspaper coupon. So we have a newspaper coupon of $50 and a 10% discount. Use composition to find the final price of the purchase when the coupon is applied before the discount. Then we're going to use the composition to find the final price of the purchase when the discount is applied before the coupon. And we want to figure out which composition will get the better price. Okay, so we have two things going on here. Number one, we're going to let X equal the price of the water skis. We're not going to work with $180 quite yet because we want to come up with an expression and a composition for each. So this is the price of the water skis. Next, we have number two. I'm going to let f of x equal the $50 discount or $50 coupon. The price after the $50 coupon, a $50 coupon price. So what that means is that we're going to have the price of the water skis is going to be reduced by $50. That's what that function represents. So f of x would be equal to, if you had a $50 off coupon, that means you're going to take the price that it originally was and subtract $50 from it. Number three, we're going to let g of x equal the price after the 10% coupon, or the 10% discount. So what that means is that you're going to pay for your water skis and then deduct 10% that I'm going to write as 0.10 of, or times, the price of the water skis. So what I did here is we have the price of the water skis minus 10% of the price. So collectively, if you were to add 1 minus 0.10, that's going to equal 0.9. So g of x is equal to 0.9 times x, or 90 times x, whichever way you want to view it. So now the first thing I'm going to do is identify what we wanted to use composition to find the final price of the purchase when the coupon is applied before the discount. So the coupon is the $50 coupon. So we're going to find the price when the $50 coupon is applied first, or applied before the 10% off discount. That's going to be on this side. And on the other side, we're going to have the price when the 10% off discount is applied before the $50 off coupon. And that's going to be on the other side. Okay. So remember that whenever you're working with compositions, you always start on the inside and work your way out. So whatever you start with is going to go on the inside. So if we're starting with the $50 coupon, that means that we're going to start with f of x being on the inside. So f of x will be on the inside, and that means that g of x will be on the outside. So we want to identify what g of f of x is. So we want to figure out what is the final price when the coupon is used before the discount. So we're talking about when the $50 off coupon is applied before the 10% off coupon. So I have f of x starting first. So the first thing I'm going to write down is f of x. So f of x is equal to x minus 50. Then I'm going to say that g of f of x would be equal to g of x minus 50. So I'm going to do 0.90 times x minus 50. Distributing 0.90 to each term, I end up with 0.90 x minus 0.90 times 50, which is 45. I'm going to leave my expression just like that. So this is what g of f of x is. So g of f of x is equal to 0.90 x minus 45. And all I did is I applied f of x first, then I applied g of x, and I was able to come up with my number. Next, I'm going to identify how much the water skis will be after they are $180. So let's say that they are $180. Now we're going to let x equal 180. So I'm going to write g of f of 180 is going to be equal to 0.90 times 180 minus 45. And 0.90 times 180 minus 45, that is equal to $117. All right, so you would pay $117 if you applied the $50 coupon first and then took the 10% off discount. That's how much you would pay. Let's go ahead and look at the other side. So when you take the 10% off coupon, if that is applied first and then the $50 coupon, that means that we start on the inside and work our way out. We're going to work with the 10% off coupon first. So that's going to go on the inside. The g of x will go on the inside, and then we'll apply the f function. So the first thing we need to do is identify what g of x is. G of x is equal to 0.90x. Then the second thing we need to do is we have f of g of x. F of g of x is going to be equal to f of 0.90x. So that's going to be equal to 0.90x minus 50. So I'm just substituting it into my f function. There's nothing further for us to simplify. So therefore, f of g of x would be equal to 0.90x minus 50. So now I'm going to let x equal 180 because that's how much the water skis are. So I'm going to write f of g of 180, that is equal to 0.90 times 180 minus 50, and that is equal to $112. So which one is the better discount and which one's the better price? Well, I'd much rather pay $112 than $117. So the better price will occur if you apply the 10% off discount before the $50 off coupon. And that is the end of this lesson. When you do this problem in your homework, you do not need to be this detailed. I just wanted to make sure that I explained every single part and every single step along the way. If you have any questions about this lesson, please feel free to send me an email or talk to me in class next time I see you. Otherwise, I hope you have a wonderful day.